We're here. Hello.
Oh, we're going?
We're on.
Hey, guys.
How we doing today?
We're going to be looking at types of reactions, like a review VOD today. So this is a culmination of everything that we've covered so far.
So you know all about the 5 types of reactions, so we're just going to go through them. I put that nice big flame on there because everyone likes things that happen with fire.
Combustion, right?
Right on. Okay, so the first one we got is synthesis. Okay, so this is when we're going to take one element or a compound and turn it into one single product.
Yeah, so we have, it's easy to see that on the left side of the equation, the reactants, you have 2 of them, and they combine to form one product.
Okay, here's another example. Oh, sorry I didn't make those little subscripts for you kids. I apologize. I know, that'll be something they'll be mad at me for. But anyway, so we're taking 2 things and making a compound again. So, synthesis. Synth, this part right here, in your FAS class, you learned that it means?
Together.
Oh, so we come together. Come together right now. Over me. It's over me?
I don't know.
Okay, so I have a man plus a woman come together and make
a family. Except they're not the same people. Oh, well.
You know, I did what I could, okay?
We get it.
Okay, makes sense. All right, so next one, decomposition. Exactly what it sounds like. Okay? One thing or one compound is going to break into 2 or more elements or compound depending on what it is.
Yeah, like in this case we have aluminum chloride breaks down to aluminum and Cl2. I always compare this to my kids like a body decomposing. The body is breaking down. They all say, ew, that's a gross description of that. Well, it's the truth. It's one body and it's breaking down into pieces.
Exactly.
Same thing here.
Okay, I like to go with this turtle shell.
Oh, like
the
an
turtle's
egg?
coming out, and then you have the egg and the turtle.
Okay.
I mean, really just because you know my obsession with the turtles, so.
Yeah, one thing becoming 2. Okay.
Cool. Moving on. That one's pretty easy. Okay, now we got everybody's favorite, kaboom! Okay, so with our kaboom ones, or combustion in this case, we're going to take a carbon-based compound, so basically anything that has C and H involved. Okay, and it's going to combine with oxygen, and remember, oxygen is always written as O2 because it's one of our magic 7, known as?
Diatomic.
Okay, di meaning 2, bonds to itself. Okay?
Atomic meaning atoms.
Ooh, look at that, breaking it down. Okay, and we're going to create carbon dioxide and water. Now, no matter what carbon compound this is right here, it's always producing water and carbon dioxide. End of story. You're not going to get anything else. So stop trying to take CH and O and put it in any special order, because it's always producing water and carbon dioxide.
Yeah, it's kind of weird if you think about it. Fire makes water, and water puts out fire. Weird. But it's such a small quantity of H2O that's made that it doesn't have a significant impact on putting out the fire.
Did you just have a sweet accent right there?
Maybe.
It sounded like it a little bit. Okay, now we got single displacement or replacement, however you want to go. Okay, so it's just like one thing is taking the place of something else. Okay, so I really enjoy the example of you're going to the dance, you're flying solo. So you're going to be Zach Zink. Okay,
here we go.
Zach Zink is going to the dance flying solo, but he sees this couple, Henry Hydrogen and Kathy Chlorine.
I was going to say Clarice.
Okay, so, well, while they're at the dance, that's what this arrow means, Zach Zink moves in on Kathy Chlorine, and guess what? Now, Henry Hydrogen,
later, you're by
he's
yourself.
on his own. Okay? So, something displaces the other. In this case, we use our activity series, and the element that is higher will take the place, because it's more reactive.
Well, what about if it's not on the activity series, or if it's below it?
Well,
what are you going to put?
No reaction.
Because it's
Nothing's
not
gonna happen.
strong enough.
Okay? So, here's another example.
My favorite.
Would you like to explain this, Mrs. Weaver?
Sure. We have Angelina Jolie by herself, and we have Brad Pitt and Jennifer Aniston. You guys are probably so young anymore, you don't even realize they were married. But they were married, and then Brad Pitt happened to film a movie with Angelina Jolie, and by the end of the movie, he is with her and Jennifer Aniston.
It's out in the cold.
Well, probably in some $1 million mansion somewhere, but she's by herself.
She's flying solo. So, single displacement, one thing or one element, in this case one person, moves in on another, and someone's booted.
Yep, that would be, actually, if you look at this, Angelina Jolie would be higher on the activity series than Jennifer Aniston, if you look at it that way.
A little more popular.
Yeah.
I like it. Okay, so then we have our very last one, and this is double displacement. So, same type of thing, except this time, the two cations or the two anions, whichever route you want to look at, are going to basically switch partners.
Yeah, so it's a double displacement. Twice things are switching. So it's just like what we did there, but with another switch added to it. So everybody's switching.
So I got a good example.
Yeah, this one was hard to figure out.
This is the Denver Broncos when, why can't I?
Kyle Orton, wasn't that his name?
Yeah, no.
No, Jake Cutler.
Jake Cutler. Oh my
Yeah,
gosh. Okay, so when Jake Cutler was playing for the Denver Broncos, and we had Kyle Orton playing for the Chicago Bears, well, they made a trade, and we so luckily inherited Jake Cutler as a new Bear, and Kyle Orton as was then changed into a Denver Bronco. So, double displacement.
Double bad news, really.
Right on. Maybe we'll eventually get someone that's good. Okay? So, that's about all we got for you. Here's a couple practice ones. Mr. Reards, do you think you could tell me what type of reaction this first one would be?
I would think for a second, I'd be like, oh, it's a replacement. But then I would look
Okay.
a little bit closer, and I would see that we have carbon, hydrogen, oxygen gas, makes carbon dioxide and water. That is a combustion every single time.
Right on. Okay, I'm going to look at this one, and I'm going to see, oh, we have one compound. It breaks into another compound and something else. So I'm going to assume that it's breaking up, so it's decomposition.
Decomposition.
Okay. This little fella right here.
We have chlorine by itself. We have sodium bromide. We notice on the other side that bromide is now by itself, and sodium chloride is formed, so that would be a single displacement. You can always tell a single displacement because you have one by itself on one side, and then on the other side of the equation you have a different element by itself.
Single.
Single.
One. Okay.
Uno.
Yeah. And then we have in this one I see one compound and another compound, and then on the other side of the reaction I see one compound and another compound. So since there's two compounds, I'm going to assume that this one's double displacement.
Yep. Go double check, make sure your cations switched anions.
Exactly what they did. And then our very last one was the easiest of all. Two
Bail.
things. One, boom. Bail. Let me say bail. Okay?
Yeah.
Questions? We'll see you in class.
Later.